Ever wondered what a microprocessor is or how it works? Well, imagine the human brain and all of its complexities. That's a microprocessor for digital devices. At its core, a microprocessor is a device that interprets and carries out the instructions that drive a computer. Just like the brain, it manages data flow, controls various hardware components, and essentially makes sure everything runs smoothly. Now, don't be fooled into thinking that these micro marvels are exclusively found in your desktop computers or laptops. Microprocessors have a far wider reach. They're found in many of the devices we use daily, from our smartphones to our smart fridges and even in our cars. Simply put, microprocessors are the brains behind our digital world, tirelessly processing millions of instructions per second, day in and day out. They are the unsung heroes of our modern, technology-driven lives. Without the microprocessor, our digital world would grind to a halt. Did you know there are different types of microprocessors? That's right, and each one has its unique strengths and applications. Firstly, let's talk about CISC and RISC. CISC, or Complex Instruction Set. Computing microprocessors have a large number of instructions. This means they can perform complex tasks and handle a variety of data types. They're like the multitaskers of the microprocessor world. On the other hand, RISC, which stands for Reduced Instruction Set Computing, have fewer instructions. They focus on executing a smaller number of instructions at a faster rate. Think of them as the sprinters in a race, quick and efficient, but that's not all. We also have single-core and multi-core processors. Single-core processors can execute one instruction at a time, while multi-core processors can execute multiple instructions simultaneously, enhancing performance and allowing for multitasking. Choosing the right type of microprocessor can greatly affect the performance of your device. So understanding these differences is key to optimizing your tech. Microprocessors and microcontrollers may seem similar, but they have key differences. Microprocessors, often found in personal computers, focus on computational prowess. They are the brain, but need other components to function. On the other hand, microcontrollers, common in embedded systems, are like a computer on a single integrated circuit. They include a processor, memory, and input-output peripherals, making them a one-stop solution for controlling devices. While they may seem similar, understanding the differences can help you choose the right component for your needs. So, what exactly does a microprocessor do? Well, at its core, a microprocessor is responsible for three main functions: data management, instruction execution, and hardware control. It's like the brain of the computer, making sense of all the information it receives and deciding what to do with it. Firstly, data management. The microprocessor handles all the data that flows through a computer system. It receives input, processes it, and then sends it out as output. This is the fundamental process that makes our digital devices function. Secondly, instruction execution. The microprocessor interprets and carries out instructions that are stored in the computer's memory. Each instruction tells the microprocessor to perform a specific operation, such as adding two numbers or moving data from one location to another. Finally, hardware control. The microprocessor oversees and controls the operation of the hardware in the computer system. It sends signals to different parts of the system to coordinate their actions and ensure everything runs smoothly. From executing instructions to controlling hardware, the microprocessor is truly the heart of any digital device. Let's quickly recap what we've learned. A microprocessor like the 8085 is the brain of a computer directing all its operations. There are various types, each with unique capabilities. Distinguishing between microprocessors and microcontrollers, we've noted that the latter integrates additional components like memory and peripherals. We've delved into the bus system, the organization of microprocessors, and the complexity of a 40-pin microprocessor. We've also touched on addressing modes and key features. Understanding how a microprocessor works can give you a deeper appreciation for the technology that powers our world.